and welcome to Hadoop Exam Learning Resources. In this session, we are going to discuss regarding the machine learning and data science. So that would be the introductory session where we will cover the basics of data science and machine learning, some examples of machine learning, what is the difference between supervised and unsupervised learning, key terminologies which are used in the in machine learning and data science, that is features, training and testing, how to choose the right algorithm, and common steps for machine learning and data science, like collecting the data, prepare input data kind of thing. We'll go through all these steps. So let me start the session with this. Okay, so the basics of machine learning. So let me go to the clean screen. Okay, so machine learning is exactly what you are asking machine to learn something, correct? This is your machine. Based on something, you are asking this machine to behave like some, put some mind on this machine, correct? And when I provide some data, so you give some reasonable output as expected. Okay, so based on some logic. So this is my machine learning. So I have teach this machine something, please learn. Okay, so this is machine learning. Okay, so let me give you an example. How does this happen? Okay, so let's say, assume it I have some data already with me, like assume it I have 500 patients data. These are the cancer patients. Okay, let's assume, sorry, bad word, but nobody likes this, but we have to do something on this. So okay, so these are the 500 patients data who, because of some out of them has been died, some was in critical situation, some was like diagnosed as a cancer but they survived, which we want everybody to survive, but okay. So for this is the like output, correct? So this is the 500 patients I have data which who has survived, and based on what exactly for these patients I have data, what kind of data I have: their age, their sex, their hereditary problem or something, hereditary cancer patient, what are the symptoms, various symptoms, their blood group, this kind of healthcare data I do have, correct, with me. Okay, so this data set is, I would say, this is exists for all 500 people, and based on, and also their survival critical situation or whatever also I have, correct? So this data set is exactly, I would say, training data set, because I want to train my system. Okay, so this data set, let's assume it, this all the data set of the 500 patients is into the one text file or some CSV file. Now I would have designed one algorithm. Okay, some algorithm I have designed. So I asked this algorithm to learn something based on this patient data and generate the output. So something learned, correct? So these symptoms, then go this, if this symptom, then go this branch, is this very simplistic terminology. Okay, so this branch, so this kind of algorithm, correct? So this is the core of this, again, engine, like this algorithm, and based on this, so I have trained based on this 500 patients. So some output will come: survival, the critical, they are in critical situation, they are died. Okay, so this kind of algorithm I have learned. Now suddenly 10 more patients data come from one hospital, and based on this this algorithm, this also provides me the similar whatever the data points which is needed, like sex, hierarchy, age, etc. And now this algorithm is ready, correct? It has been trained by 500 patients data, and based on this, okay, I would, now this algorithm is already prepared, and I and it will tell out of 10% 4 will survive with their own name. Like 1 would be died, most very critical situation, and uh, 5 would 5 are in critical situation. So I've already trained this algorithm based on this. So it's like, I would say this algorithm has experience, like I do have experience, so based on this I can tell something, correct? So similar to this, I have given the experience to this algorithm, like based on some factors you decide what exactly would be the output. In this case, if the parameters is this, so this is the training of the algorithm. So this is exactly the machine learning in data science, correct? So this algorithm can be written any programming language, Java, or this could be plain algorithm, correct? This formula, correct? Anything it could be, like Python, Scala, whatever, any programming language, MATLAB, R, there are various. So that is the machine learning. Okay, so very basic example. So as a data scientist, you have to find it out, like what exactly the, like you have to design this algorithm, you have to find the output, this all you have to do this. So now here you see this divide into 3 parts, correct? My data is divided into, classified into 3 parts. So that is a classification problem of the machine learning. So there are various algorithms you have to design. So this is classification, because my data I'm classifying in 3 parts. So that is why this is the classification algorithm, correct? So this is the training data set, as name suggests, I've trained this. Okay, so this is the features, actually the parameters which the data, like what are the features here? Age, sex, hereditary problem, blood group. These are the features, exactly these are the features. This terminology you have to remember. Okay, little bit confusing, why they cannot give straight name, I don't know, but that is the called features. Okay, so this you can see parameters, like every programmer can understand, but now they keep creating this statistics guys are, I don't know why they give different name. Okay, and the output, correct? This classification, this is the target. What is my target, correct? This is my algorithm, this is input data. What is my target? I want to find it out, like patient will survive or in the critical situation or will die, correct? So this kind of things I want to find it out. So this is my target. So this is the features, correct? This is the training data set. And again, one point I forgot, I will tell you in the next few minutes, like testing data set. Okay, so this is a classification problem. So this is one kind of the machine learning. Okay, so let me give you again the machine chart where I would define what exactly the machine learning divided into multiple parts. So this is your machine learning. Machine learning you can divide into the 2 part, exactly, supervised machine learning and unsupervised server. So by name again you can determine what exactly that mean. Again, this is statistical terminology. Okay, wonderful, you have to read a lot to understand this. Okay, supervise, somebody is supervising my algorithm, and there's nobody who supervised my algorithm, the simple meaning. So who is supervising my algorithm? Training data sets, they are supervising, correct? So if you are working in the supervised machine learning part, then you would always have a training data set, keep in mind. Okay, training data set and some target output would be predefined. That is supervised learning. And unsupervised learning, there is no training data set as such, and there is no there could be training data set but not a target value always. What target? So this is unsupervised learning, very confusing terminology again, but we have to remember. So now supervised learning can be divided into 2 parts, classification and regression. I'll tell you what this all means. So classification you have already seen, like we have divided into the patient. This is 3 categories. So this is the classification to classify in 3. So my target output is defined. I need my patients to be divided in either 3 category, either died, survive, or critical situation. So what exactly? So here target value. So this target value is defined. So based on the target value, you define your algorithm. If the target value is nominal, like nominal, not nominal is again not a good term. Normal, like I would say, I can explicitly say either survive, divide, or something, or some integer, or sorry, some proper classification, like some integer value, like true, false, could be the output, or critical, died, or survived. This kind of output is expected. Or I am doing the email filtering, like Google nowadays doing the email filtering in three part, correct? Social networking, marketing, your main email box, and spam filter. So this kind of filtering you are doing. So this is all classification where my target value is defined. This is nominal value, correct? In election, who would win? BJP, Congress, which party will win? Or nowadays AAP is popular. Okay, so this party, who would win, correct? So that could be the classification problem, exactly. So this is classification. If my output is like 0 0.1, 0 0.2 something, this kind of value, like stock prices will how much stock price gain I would get it, like this kind of problem is a part of regressions. Like stock price would be tomorrow would be 110 for the some IBM or something, or some Google, the next day stock price is $200 or something. So this kind of you are doing, like some like value comes as such as 0 0.10, 0 0.20, 100.1 or something, this kind of output comes in, then that is a part of the regression, correct? So you remember the how classification and regression is divided. Unsupervised learning is like, I will tell you what exactly that mean in future session, but sorry, in a few minutes. Okay, so but right now remember, so this is machine learning divided in supervised and unsupervised learning. That is a classification and regression problem. Okay, so exactly data scientist, if you want to become a data scientist, then first part I would say you should have IT and software programming knowledge or some good programming skill set, correct? So you should be computer science guy or IT guy, or you might have worked in this industry since last few years, like 9, 10, 6, 5, 4 years or something. So this is the second part is statistics knowledge. If you are statistics guy, then it's good, very good for you. If you are not, then please learn the statistics to become a data scientist. That is very interesting subjects actually to learn. You have like in your previous mathematics, you have learned many statistics parts and you don't know what exactly that when where it is being used. So now you can find it here, like this statistics is being used here in the data science. So this is very important. So you might have ignored your schooling or something, or in college time. So this would be now useful for you, and now you will learn definitely with me. Okay, so now engineering and manufacturing. So what here I mean domain knowledge. Again, so like this is again different field, correct? So now you are working in since last 5 years in finance domain, in healthcare domain, in technology domain, in telecom domain, in manufacturing domain, in retail domain or something. So this domain expertise you need it. So combination of all these three would actually make you the data scientist. Keep in mind. So data becoming a data science is not easy and not even tough, because you can definitely learn all these things. So that's why this is the sexiest job of the 21st century, because you need all these three knowledge all together, and this is all three needs extensive experience, knowledge, and brilliance, good mind, etc. And obviously keep learning is always good thing here. So it can be applied, so data science can be applied to your politics, your geoscience, your finance, your media, social engineering, or social networking, many things. Okay, so this is what here. So through the here we have discussed about key terminology, features, and learning. Okay, so okay, I have considered this all part, so let's move ahead. So in classification, our job is to predict what the instance of the data should fall into, in which category the data instances fall in, correct, true, false, critical, died, or something. Regression is to predict a numeric value. Okay, so like stock price, I have told you. Classification and regression are example of the supervised learning. Unsupervised learning, there is no target value, correct? Sorry, so training data set could be there, but there is no target value. no target value defined. So what would be my output? I cannot like predefine something, correct? I don't have predefined this. So a task where we group all similar data together called is clustering. So here the example is clustering. So K means clustering. You would be learning in future sessions. So this is part of uh, what I would say unsupervised learning. So you cluster your data according to like I'll tell you by example so, okay, in few minutes. Density estimation. So in density estimation is another part. In density estimation, you again in this we want to find statistical values that describe the data. So what, how dense is the value? So this is again example will help you right now. I'll just tell you the name again. What is unsupervised? Another task of unsupervised learning may be reducing the data from many features to a small features, because sometimes what happens, like you have taken hundreds of parameters for your data, and this parameter might not be helpful sometimes. Suppose let's say if you're predicting for the elections result or some election is a part of classification problem, but somewhere in probability I want to say like stock prices or something. So what is the name of the company? Based on this, what is the full name of the company? Is there a point of having like predicting the price of the stock? No. So this kind of features needs to be removed from the data set. So you so your data storage would be reduced and your algorithm would be faster. So this kind of algorithm which reduce the features which are not needed and no point of having that into the my algorithm is a part of like unsupervised learning. So this is what about like uh, and then you should be able to visualize your data. If there are hundreds of points, so how would you derive your graph or something multi-dimensional? You can derive graph 4D or 3D, maximum or 5D. So like in how many dimensions you can show your graph? So if you reduce your dimensions, then it is best thing. Like and but the correct result is expected with the reducing with the so these are all about the example of the unsupervised learning. So we'll discuss about them in later session or in few minutes for the example. So how to choose the right algorithm? So now there are various algorithms we have discussed, correct? So for my perspective, which one is the right algorithm? How can I choose these things, correct? So find your goals. What is your goals? First you need to find it out. Do you want to get probability where it will whether it will rain or not tomorrow, kind of probability you want to know? You want to find groups of votes with the similar interest, like vote goes to the BJP or Congress or AAP or any political party. So if you are trying to predict or forecast a target variable, correct, you have target like which party would win, BJP, Congress or up some this three party. Out of this, who would win, correct? Or tomorrow there would be rain or not, correct? So this you want to find it out. So this prediction is so now what would you be your targets, correct? We have this. So this is the problem of classification. You clearly said like BJP or Congress or up. Then this is a classification problem. You have your target value. If the target value is 0, 0.0, some probability 0, 0.1, 0, 0.12, 13 or 13, so then this is the problem of the regression, correct, as we have discussed. So you need to get into the regression part, right? If you are not trying to predict the target value, then go for the unsupervised learning. Okay. If you're trying to fit your data into some discrete groups, then you should use the clustering. So like in which group it would fit into this. It's again not classification, like in which group. So while clustering we'll discuss this like where my data point fits in. So this is part of the unsupervised learning. You need to have some numerical estimate of how strong fit is into the particular group. Then you can again you should use into the density estimations, correct? So this is again unsupervised learning. However, you have to keep understanding your data in depth understanding of the data is required. Keep in mind that is very important part to like choose the right algorithm. What is you want to predict, what is my input data set, what is my training data set or something. So common step for implementing the machine algorithm and data science. Okay, so let's start with the steps which we are going to discuss. So first step, what can you imagine, like what would be your first step? You must have data, correct? Collect the data. So if you want to implement algorithm or something in the machine learning, then you should have data. You could get simple data like from the website scraping or public API, like you can use API to fetch the Twitter feeds, all Twitter feeds you can fetch it, or from the Yahoo Finance you can get the all financial data or something. Healthcare data is private, it wouldn't be easily available, only company can give you who are having this. Measure the wind speed for windmill analysis, sensor analysis, something. Use publicly available API as I have said, or social networking data like Facebook data, Google Plus data or something to be there. So this is to collect your data first. That is the first step. Now once you have collected your data, then prepare this data, correct? Now I have my data, correct? Prepare data, but it could be like in XML format or in semi-structured, unstructured data, movies data, audio data, and that would not fit my algorithm. Then I have to transform this. So I have extracted this data. I need to transform this data into the format which my algorithm can understand this. So that is very important point. Once you have the data, convert in useful format like HDFS, store in HDFS file system, HBase like store in the tabular format, XML format, or whatever your algorithm can handle this. So some algorithm use data in a particular format like string integers, so this is really easy step relatively. It's not that tough step, so software engineers can help you to this implement this. But if you are a software engineer side, so you can also understand like create this data. So analyze the input data. Now my next step would be analyze the input data. You are data scientist, you must be able to understand your data. Just looking your data, you should be able to check the data you have if you are expecting as expected data, like the format which is created in above steps, like in this step is as I need it or my algorithm expects it. So for example, while analyzing voters behavior, you should have their sex information, age information, interest, current issue, education, poor, rich, or etc. information is needed. But it is not useful information like whether what time they wake up in the morning. So is this useful information? So no. So remove this information from your data set, because that is not going to help in your algorithm, and it would be a dirty data for your algorithm, which could harm your algorithm by making it slower to cleaning the data. So you should be able to clean this data in the previous step itself. You should not do this in this step to make your algorithm fast. So you need to data which is relevant as possible. So relevant data selection is important. Okay, so now let's move to the fourth step of machine learning, like train your algorithm, correct? So there is, you put your lot of effort, train your algorithm. However, each step is require lot of effort. This is my fourth step. So what train means, I would explain. Previously I have explained, sorry. So this is my algorithm, classification algorithm or something, and this is my input data set. Based on this data set, my algorithm will learn, and based on this it will generate some output, clustering, classification, whatever is the algorithm it is there. So this is the training data set. You have trained your algorithm. This step is useful only in case of supervised learning. If there is no supervised learning involved and this is unsupervised learning, then there is no training steps comes into this picture, because there is no target values defined in the unsupervised learning. So how would you train your algorithm, correct? You feed the algorithm a good clean data from the first two steps and extract the knowledge or information out of this, correct? This knowledge you often store in a format that is readable or usable by machine for the next steps, correct? So this is training data set. Now you have trained your algorithm, correct? Now previously I told I missed one step, that is testing. Test your algorithm, correct? It might like training something wrong had happened, it possible, correct? But even training, so how do you make sure your training algorithm like algorithm you have trained is perfect? So you have some test data, which is like for this test data you have predict output value as well as input value. So you push this input value to this and the output value will come. So if you are a Java guy, you might know the JUnit test cases, correct? So in JUnit test cases, you know your expected output in advance. So similarly here, like this, I know my expected output and this should match it. If doesn't match, then my algorithm fails, then something is wrong with the algorithm. If this match, then this is good. So this is my testing of the algorithm. If this pass, then my algorithm is good to go. Okay, and the last step is of machine learning is obviously I have designed my algorithm, then use it. So this is algorithm which I have designed. So my daily data feed comes, keep coming, and this goes to this algorithm, run it in parallel if massive data, and this all, and based on this some output would be generated, right? Some output will be generated, and this output can be used by the further like or can be stored in the database for further use. So that is like in NoSQL, HBase, Hadoop, Oracle, somewhere Cassandra, whatever, wherever you want to use it, or you based on this you generate some graph, or you can like this is your web page, this is your video which is you're watching right now. Based on some the algorithm, the recommendation would be generated. So this is recommended video to watch, and this is actual video you are watching it. So this is based on the machine learning algorithm, this video would be predicted. Similarly, like stock prices, like today IBM price is $100, so possibly after 1 month the price could be $110, or something in the next week it could be $110. So this kind of prediction is possible. So this is your algorithm which you will be using for your what I say machine learning to predict the data. So there are various programming languages which help you to implement these things, correct? So this is like infrastructure is there, but there are various languages which like R language, which is very popular in case of the machine learning. Similarly, the MATLAB, and this is Python is another programming language. Obviously, Java would help. Then there are other languages, SAS platform. Then EMC has their own machine learning library, that is MATLAB. Then there are Spark is keep coming right now, which is very popular framework from Apache side. So these are all framework and languages which would be learning, you are learning for the data science. So that's what, and at last what I wanted to tell you, very important thing is to subscribe this YouTube channel, because we are keep adding new and new session which would be you will be keep getting the updates based on this whenever we add new videos, or you will get it, or we paste a comment on the video, you will get it, because this would help you in your certification preparation. So this tutorial will help you EMC data science certification practice questions, and as well as the Cloudera data science certification, or anywhere else like if you are going to prepare for the data science certification. So as a hadoopexam.com, we are providing the data science certification and Hadoop certification. So let me go through the website to show you the things exactly what is we are providing. So this is hadoopexam.com, already I opened previously. So hadoopexam.com provides various certification preparation solution as well as Hadoop training and HBase training, which would will be coming, and Amazon Web Service. So you can go through this here, like CCD development, Hadoop developer, this is Hadoop administration, this is Hadoop training, this is HBase certification, this is database science certification for EMC, and this is Amazon Web Service certification. So there are various solutions we have for Amazon Web Service, and similarly for the SAS certification. So we are keep coming on the like various solutions to provide you and to help you to prepare for the certification and to train you for the and many things. So please I would suggest you go through this website once and subscribe this YouTube channel, as well as this quicktechie.com is our another website where the profiles are being created by the users who are interested into the big data domain. So you can create your profile over here. Like you can see here, there are various profiles that are available. So this would we will help you to this guys to like get the what I would say like job as well, because we provide the recruitment solution as well and consulting as well. So thanks for watching, and I hope wherever you need help like consulting for doing business with us, please contact us. Thanks for watching.